Hey guys, here's your review for your test on the foldable. The test is truly over the properties of logarithms and our exponentials. And so here we go. It says rewrite the equation in exponential form. So we're going to boomerang. We always start at the base. Throw the boomerang as far as you can. So we start at the base 2. That means we go all the way over to the 3. We set it equal to, bring your boomerang back, zoom, 8. Now, when you rewrite it, it should make sense. Does 2 cubed equal 8? Uh-huh. Yeah, it does. Okay, so it makes sense. All right, boomerang again. Start at the 5, over to the 2, then the 25. 5 to the 2 equals 25. Does it make sense? Yeah, 5 squared is 25. Again, the 9 to the 1/2 equals 3. Does 9 to the 1/2 equal 3? Well, 1/2 is the same as square root, so yes, it works. Excuse me. Now it says evaluate the log without using a calculator. What we're going to do here is say to ourselves, this is a base 3. I know what 27 is. 27 is really 3 cubed. So I say it's log base 3 of 3 cubed, because 27 is 3 cubed. Now, grab my color, because log base 3 of 3, zoom, goes away. And what got left behind? The answer is 3. Now, 5 is kind of like a trick question. You need to know this. What do you need to know? Well, you need to know that the log of 1 is always 0. But why? Why is the log of 1 always 0? Well, I'm going to give it to you. Here's the log base 4 of 1. It equals k, because my name's Cassie and I love drawing k's. That means 4 to the k power is 1. All I did was rewrite it just like we did on numbers 1, 2, and 3. Well, think about that. 4 to what power is a 1? 0. 0. There you go. Now, the same kind of rules are applying here. Let's do number 7 first. If you look at this, this is log base 15 of 15. All that bit here, gone. Answer is x. And 7 to the log base 7 of x, gone. The answer is just x. Okay. I tried to do this so that it would show everything in the video and not have the problems we were having last time. Let's see if it'll work. All right, now for finding inverses, all we do is we switch the x and the y. So remember, this is really y equals log base 3 of x. So I have y equals log base 3 of x, but I need to switch the x and the y. So x equals log base 3 of y. Now we're stuck. I'm like, I have a log. I don't know what to do. Well, I have logarithmic form. If I write it in exponential form, maybe it'll make sense. So we're going to boomerang. Always start at the base. The base is a 3. Shoot your boomerang as far as you can. Whoosh! That means it goes over to the x. And then bring it back again. Ooh, it's a y. Now check this out. To find the inverse, you switch the x and the y, and then you solve it for y. Did we solve it for y? Why, yes, we did. Okay, that's that one. Same idea for all of these. So keep in mind that this is a y. So the first thing I do is I switch those. So I get x equals log base 2 of y minus 1. And I'm saying to myself, oh no, I don't know what to do. It's a log. I'm stuck. It's a log. And then I'm like, oh no, I'm not stuck. I know how to rewrite this in exponential form. So what I do is I say the boomerang. It starts at 2, throw it as far as I can, means it goes all the way to the x, and then it equals, come back again, y minus 1. Add the 1 to both sides. Now, can you actually add the 1 to the 2 to the x? No, you cannot. And so that's what you have. Okay. I'm going to need to make myself room somehow. I'm going to try here to move this. Moving that problem over there. See what I just did? And then I'll draw you guys an arrow. There it is. All right, let's try this next one. I'm bringing it down here just to be easier on me. it is going to be x equals log base 4 of 16y. I'm in log form and I'm stuck, so I rewrite. So 4 to the x equals 16y. I divide by 16 on both sides. The 16 and the 4 do not play because the x is protecting them. So I am either done with 4 to the x over 16 equals y, or I'm allowed to say that it's 1/16 times 4 to the x equals y. Doesn't matter, guys, whatever you want. Okay, I'll change colors for you. Yay for purple. Bringing this natural log one down here. First, remember it's a y equals natural log of x. So we switch it. It's x equals natural log of y. And then you're like, wait a second, natural log, it doesn't have a base. What's the base? It's an e. So this is just e to the x equals y, and bammo, it's done already. I love logs. Sometimes they're quick and easy. Okay, let's go to the next page here on the back. It says use the properties to figure stuff out. Okay, they're giving you the log of 3 and the log of 4. We're not allowed to do these in our calculator. We're going to like write this out. So everything we do is going to be 3s and 4s. So look here at number 12. It says it's the log of 3 divided by 4. And you're like, whoa, division. What really is division? Well, division is really subtraction. So this is really the log of 3 minus the log of 4. And the log of 3 is 0.477. And the log of 4 is, so hold on, minus 0.602. And now I can do that by hand. See, that's why in the good old days before calculators, like this was rock star method of getting things done. But now that we have our calculators, we could technically cheat, but it's negative 0.125. All right, now number 13 is different. It says log of 12, and you're like, 12? They didn't give me 12. But they did give us 3 and 4, and we are smart. And we know that 3 times 4 is in fact 12. And we learned that multiplication is really just addition. So this is the log of 3 plus the log of 4. So now you get that value for the log of 3, which is 0.477, and you add it to the 0.062. And when we add those, I think we get 1.079. Now, number 14, check that out. It's 4 over 27. You're like, 4 over 27? Where the heck does 27 come from? So you have to really be thinking. Remember, 27 is 3 cubed. So this is truly saying the log of 4 over 3 cubed. So the first step is to expand that. That's the log of 4 minus the log of 3 cubed. Then when we go to expand it, we're like, hey, remember the power property says the powers are truly multiplication. Remember, exponents are truly multiplication? So this is the log of 4 minus 3 times the log of 3. Well, that's 0.602 minus 3 times that other decimal, 0.477. And it looks like I never even did that math, so you guys do that math yourselves. But at least that's how you do it. Okay, expanding. Expanding is when you start with one log and you end with a bunch of logs. So I would count. There's a 3 here and an x here. There's a 3 and an x. That's 2 things. So how many logs am I going to have? 2. So they are going to be separated with an addition because addition is multiplication. So I separate them log base 6 of 3 plus log base 6 of x. Done, just like that. Now that's the way I think about it and do it in my head. If you're doing it in your head a different way, go for it. That's fine with me. You know that. All right, number 16 here. I'm looking at this and I'm like, hey, whoa, there's division. So I know there's going to be a subtraction sign somewhere, and now I'm going to count them up. I've got an x, a y, and a 3. So I'm going to have a log base 4 of x, a log base 4 of y, and a log base 4 of 3. But now how do I know who gets plus signs and who gets minus signs? Well, the denominator is negative. Remember, he's down so low, he's so sad. So the 3 was in the denominator, which means that's the negative one right there. And that y was in the numerator, so he's positive. Yay, happy y. And then the x was in the numerator also, so make sure there's an invisible plus sign out in front of the log base 4 of x. Okay, that's how I do it in my head. Number 17, here we go. I'm just going to change colors for fun. The square root of x is really x to the 1/2. Do you remember that from like last month? Square root of x is really x to the 1/2. Okay, so I see a 2 and I see an x to the 1/2. So I'm going to have two logs. So log base 5 of 2 plus log base 5 of x to the 1/2. The problem is I'm not done. I'm not done because that 1/2 power needs to come down because powers are actually multiplying. Exponents multiply. Math is so crazy. Okay, so here's what we've got. We've got log base 5 of 2 plus 1/2 log base 5 of x. And that's our final answer. Excuse me. All right, here we go with a natural log problem. Take a peek at it. I've got a 3, I've got a y, and I have an x to the 1/4. That means I'm going to, oops, it's a natural log. I'm just going to turn that into an n, okay, guys, instead of trying to erase. So natural log of 3, natural log of y, and natural log of x to the 1/4. 3 is up on the numerator, so it gets an invisible plus sign right here. Y is up in the numerator, so it gets a plus sign. And then x to the 1/4 in the denominator means it's negative. Now we're not done yet because the 1/4 has to come down. So I'm going to rewrite this one last time. It's the natural log of 3 plus the natural log of y minus 1/4 natural log of x. Okay, over here. Hopefully you can still see it on the screen. It's condense. Condense, I personally think is easier because you're going down to one log, so you know your answer is only going to have one log. So here we go, 1 log base 3. And it's going to be of stuff. And the question is, what kind of stuff is it? Is it a product or is it a quotient? Now you see a minus sign, so you're like, hey, it's division. 7 has a positive log. See how this is an invisible plus sign out here? That means 7's on top. X has a what kind of log? A negative log. So that means it's on the bottom, and you're done. Negatives mean they're in the denominator. Okay, on number 20, you can't start this until you recognize that the 2 is going to be the power of the x, and so it's going to be an x squared. All right, so what we have is 1 log base 5 of stuff, and the plus sign means we're multiplying. So it's going to be an x squared times a 3. So just rewrite that log base 5 of 3x squared. Okay, so for this one, what we first notice is that we've got the 2/3. We're going to stick it up here as the exponent on the x, and this 3, we're sticking up here on the exponent as the y. And the second thing we want to notice is that subtraction sign means when we have the log base 2 of stuff, the stuff is going to have division because subtraction is division. Okay, so this is x to the 2/3, and this is y cubed. And we're done. All right, now let's look at 22. 22 is awesome. It is super exemplary of really critical thinking about what minus means. Minus means division. So you know at the end of the story you're going to have one natural log of stuff because that's what condensing is. And so this 3 is going to go on top of the x, and the 2 is on top of the y, and the 4 is on top of the z. Now pay attention to your minus signs. The x cubed is with a positive natural log. So the x cubed is in the numerator. But the y squared is with a negative natural log. So y squared is in the denominator. And then the z to the fourth has a negative natural log. So where does z to the fourth go if that natural log is negative? It actually goes in the denominator. And that is a great problem. Okay, I know the music is on to get to class, but let's just do these last two if we can. Hopefully you can still hear me. Remember what the change of base formula is. All they want us to do is write our log of x over log of 3. That's it. That is the change of base formula. Okay, and woo, we've got arrows all over the place. Y equals, it's the log of what goes on the top, what goes on the bottom. The x plus 3 hangs out on the top, and the 6 on the bottom. Okay, we've got a test coming up. I hope you're doing great on this and having a good day. Bye, guys.